All right, we're asked to find the x, y, and z components of the vector p here. And because this is statics, everything's got to be in static equilibrium. So I'm assuming that the two forces here are, well, they might make a resultant, but no. We are asked to find x, y, z components of the 535 Newton force. The 3D vector. And there's an 800 Newton vector right there. Where are they related? Well, let's list where F1 and F2 are, and I don't know. Um, I always just do left and right. F1, F2. So F1 is going to be, oh, we're given all angles. So this isn't even in like the right notation. So we're 30 degrees from X. 40 degrees off of Y going down, but everything's notated positive of X, not negative from Y. So 50 degrees. Wow, I don't actually even know X, Y, Z components. It would be nice if we can somehow get this into a vector. Well, it's going to be cosine, sine. Okay. Is it that simple? I don't think the other vector is going to really have any play. It's not really connected to it in any way. So I'm going to try this. But then what's Z? Is it tangent? Cosine, sine, and tangent? That doesn't make sense. Okay, looking into the notes, this is a very odd way of expressing a vector. It's the only one I've seen so far that's like this, but I do have a little bit of a cheat sheet that tells me that f of x equals f cosine theta x, and f of y equals f cosine theta y, and lastly fz equals f cosine theta z. Very simple. So I don't know, let's try it. That means that, I don't know, I'll say p of x, why not? Just to have some fun. Let's have some fun. P of x equals 535 cosine, that's going to be z, it's going to be y, where's x? Rise, theta x. I actually don't know what that's supposed to mean, because you can take this vector and you can raise it up and down, and you can push it, you can twist it that way. So this is z, this is y. Would x be the magnitude? That doesn't make sense. Also, oh my gosh, I take back everything that I just said. Give y 535 cosine theta y. You know what? Theta x, theta y, theta z. You know what theta of y is? It's 40. It's from, whoops, if I erase, yeah. It's freaking from the vector y, which means from vector z, theta z has got to be equal to 90 minus 30, 60. Goodness me, 60. Theta x, I don't know how to get to theta x. But you know what I can do? I can say f of x equals f sine theta y cosine something else. That symbol, is this going to be from the x direction? No. That would be this guy. This is that. How crazy. How actually stunning. This is a very interesting problem. So that means that f of x is actually 535 sine of 40 cosine of 60. That one looks good. Now we can have fy. And then z. This one's going to be x, but instead of sine and cosine, it's just going to be sine and sine. So it's going to be 5. I can just write it down here. Z equals f sine theta sine, I don't know, phi. Anything that's not theta is phi. And let's see, 535 cosine 40. I'm getting 409.83. And then getting 171.94. I call it 95. And I'm getting 297.81. So now we have f of x, y, and z, or p of x, y, and z, to get the theta x, theta y, theta z. I think we're asked for, because I think it needs to be x, y, z components. Let's see, what was the question? X component z. Okay, wait a second. Yeah. Let's see if we're accurate. So P of X, 171.95. The other one is 409.83, and then this one is going to be 297.81. And one of them's right. Huh? Of course that one's right. What's wrong with these ones? Nothing. Yeah, there's nothing wrong with them. Sine. Perfect. Yeah, it's looking beautiful. It's dead on. The input them wrong? Don't think so. It's looking beautiful. Looking absolutely pristine. Wait. I know the problem. I know the problem. That's a 30, not a 60. That's it. That's the only problem. This should fix everything. Thirty. So this one was right. 409.83. There's no way. It just swapped them 171.95. Yeah, get this. And then 29. It just swapped Z and X. So yeah, that's fantastic. Theta Z, I don't believe is going to be 60. I do know at least I do know that theta y is 3 because we do need to know these three also. And to get them, it looks like it's going to be the cosine inverse of the force, force in the direction over the force. It's going to equal the theta of the force. So let's try it. Inverse cosine of 297.81 over the whole thing is what, 535? Getting 56.17, and for the Z, that one's 171.95. And for that one, I'm getting 71.25. So let's see if these are all right. Yeah, they're all right. That's how you do the problem, son. That's how it's done. I apologize for the rough start.